Hi everyone, welcome back to Coding 101, and in this video I'm going to be talking about recursion. So recursion is basically just a function that calls itself. So I'm going to do just that. I'm going to create a function that calls itself, and I'm going to call it fun, and I'm just going to call it, and then I'm going to execute that function, and I'm going to run this code. And as you can see here, you actually get an error. It says recursion error, maximum recursion depth exceeded. That's because when you do something like this, when you call a function that calls itself, it basically creates sort of an infinite loop and it runs the program to the ground, which gives you that error here. So basically, why do you do recursion? And how do you actually do a recursion where you actually avoid this error here? I'm actually going to demonstrate this by creating a function where you can accomplish it both in a recursive way and a non-recursive way. So this function, I'm going to create basically what is called a Fibonacci function. So if you don't know what Fibonacci numbers are, they are basically sequence of numbers, and it starts with 0 and the next number is 1, and after that it will increase. It will basically be the addition of the previous two values. So the third number will be 1 and the fourth number will be 2, and then it will go to 3, 5, 8, 13, and it will go on and on and on. So that is basically a Fibonacci sequence. So I'm going to create a Fibonacci function which basically says that I'm going to put in a Fibonacci function with an input, and if the input is say 1, so I want the first number in the sequence, it should give me 0. And if let's say I want to get the fourth number, I'm going to say fifth number, it should give me 3, because the fifth number is 1, 2, 3, 4, 5 is 3. So the first way I'm going to do it, I'm going to do it the non-recursive way. So the non-recursive way is basically called the iterative way, which uses a for loop. So I'm going to put that up real quick. So I'm going to create a function called fib and an input n, and what I'm going to do is I'm going to create a for loop in range of n, and what I'm going to do is I'm going to initialize an array called numbers, and what I'm going to do is I'm going to check if I is less than 2, and what I'm going to do is I'm going to append I, and if it is not less than 2, so I'm going to put an else statement there. I'm going to say numbers dot append. I'm going to say numbers, and I'm going to take the previous two value, which will be I minus 1, and I'm going to say I'm going to add I minus 2. So that's the previous number here, and then I am going to return numbers, but I don't want the whole list there. I just want that sequence there. So I'm going to put n minus 1 actually, because it's 0 index. So I'm going to just quickly run this and call this function here, and I'm going to say I'm going to put fib5, so we know that it will be 3. So if you run this, yes, you get that number 3 there. That is the fifth number. I'm gonna just quickly test maybe the seventh number, and it gives you 8. So this is how you do it the non-recursive way, the iterative way, using a for loop. And this is one way of creating this Fibonacci function. So I'm going to show you how to do it in a recursive way. So I'm going to call this new function fib recursive, and the same thing, I'm going to have an input of n, and I'm going to say if n equals 1. So if I'm asking for the first number in the sequence, I want to return the first number, return 0, and I'm going to check if n equals 2. I'm going to return 1. So if it is not the first or the second number that I want the addition of the previous two numbers. So I'm going to do a return statement, and I'm going to say I'm going to return fib recursive n minus 1, and then I'm going to add n minus 2, so the previous two values here. So what I've created is a recursive version of the Fibonacci function, and what it does is it provides for two base cases and a recursive case. So the base case is basically the case that doesn't call itself again. So in this function, the base case is either if it's 1 or 2, it will return 0 or it will return 1. If not, if it's more than 2, then it will do your recursive calls here. So if we run this code here, if we run this function here, I'm going to run it and fib recursive, and it should give you the same numbers here. So you see here it gives you 8 8, so it works the same way. I'm going to just say 5 just to be sure. It works the same way, gives you 3 and 3. So that's the recursive way. As you can see, basically both ways work fine, but in terms of the recursive way, it actually looks a lot neater and it looks a lot more understandable here because you don't have the for loop. So it might be more efficient to do it this way. And yeah, so basically there are a number of functions that you might need to code where actually using a recursive way is actually much better and much more elegant solution. So the only thing you have to remember is that a recursive function needs a base case, needs a case where it does not call itself anymore, so it will actually terminate its call and it doesn't call an infinite loop. So that is basically recursion here. And I'm going to end this video, and this is actually going to be the last video of the series Coding 101. We've actually gone through quite a bit, and the objective of this video series was actually for people who have no knowledge of coding to get their feet wet. And I think we've covered quite a bit in coding for them to understand and maybe learn more in the future. So for those who've actually watched this video, I want to thank you. And this is not the last video. I'm going to start new video series soon. And if you like the content, you can just drop a like, hit subscribe, maybe hit the bell for notification. And I'll see you guys soon when I create different videos in the future. Until then, I will say goodbye.